Hi everyone, good evening to all. This is in continuation of videos on centrifugal compressor. Today's discussion is working principle of centrifugal compressor. I hope this video is going to be very interesting. So please keep on watching until then and don't forget to hit the bell icon. So let's begin the discussion. Working principle of centrifugal compressor. This is impeller which is rotating on clockwise direction. This is same thing, it is shown here. This is impeller I. You can see this is impeller I. And as impeller is rotating, gas is also rotating. So you can consider this ball is a gas molecules which is also rotating. Since there is a rotation, there will be centrifugal force which is acting on outward direction. But since gas molecule is trapped in between the two vanes, so it follows the shape of or profile of the vane. That is why it is moving outward and it is coming out exactly the vane profile. Please note that when the moleculus is far away from the center, the centrifugal force will be more, and this is how the principle works. So the moleculus which is coming out now, there is a lower pressure at the impeller eye, and so the gas from the suction side rushes to the impeller eyes, and this is how centrifugal compressor works. Now this is the you can see this is a actual flow path suction of the compressor, and this is discharge. Same thing it is shown here. This is suction, this is discharge, and here also it is shown. This is casing. Then we have we have casing. Then we have diffuser. Then impeller. So gas is sucked here, then travels outward from the impeller, then goes to diffuser, and then finally it follows the path of casing and then finally comes out. So centrifugal compressor is having axial inlet and radial outlet flow machine. The flow of fluid is always in axial direction at inlet. However, as impeller rotates, the velocity of fluid striking at impeller inlet at an angle which is called impeller inlet angle. The velocity at which fluid enters at impeller inlet is called inlet relative velocity. As the fluid flows through the impeller, relative velocity starts decreasing due to design of larger cross-section area of the impeller at outlet. The velocity at which the fluid comes out from the impeller is called the outlet relative velocity. The fluid doesn't exactly follow the outlet blade angle of the impeller, but it gets slipped away from the outlet blade angle in opposite direction of the rotation of the impeller. And due to this slip, the head rise is reduced. Typically, outlet relative velocity is decreased to approximately 50% of inlet relative velocity. So what is says that the profile of impeller is such that this is increasing in cross-section area, and that is why relative velocity starts decreasing, and it is approximately 50%, and it should come out exactly the blade angle, but it is getting slipped at outlet. Now the internal cross-section area of in a compressor inlet, this is IGV. This is inlet guide vane. The flow is controlled here, then comes here. It is impeller I travels. Area is increasing, so the relative velocity at outlet impeller is lesser than inlet, approximately 50%. And then comes here. It is called vaneless diffuser. In fact, the casing acts as a vaneless diffuser. There is no additional material here. It is just a gap between the vane diffuser and impeller outlet. So the gap is called vaneless diffuser, and it is diffused because it is diameter, outlet, it is considered diameter. So it coming out, so area is increasing. That is why it is diffused here. Then comes a vane diffuser, and then where again the this velocity decreases, and then finally comes to the casing and discharge out. Same thing shown here. This comes a inlet guide vane, then enters impeller eye, then comes out, impeller outlet, then there is a space called vaneless, then it goes to van diffuser, and finally goes to casing outlet. Same thing shown with another view for IGV. The same thing, IGB, another photograph is shown here. IGV, this is IGV, this is IGV, this is actuator which operates IGV. Now the construction with ITV, inlet throttle valve. This inlet throttle valve which controls the flow, then again follows the same principle. It comes to impeller eye, then again relative velocity decreases due to diffusion, then goes to vanless diffuser, then van diffuser, and finally comes out from the casing. ITV is shown like this. Although the fluid comes out for the impeller has a less relative velocity, because we have seen there is a diffusion because of larger cross-section area of impeller at outlet. But due to the higher outlet impellative velocity, outlet absolute velocity becomes very high, which has very high kinetic energy. That high outlet absolute velocity is required to be converted into the pressure. The conversion of high velocity is done in the vaneless diffuser, van diffuser, and the casing. Construction of diffuser is having increasing cross-section area, so velocity decreases and pressure is converted. Casing is designed for a spiral shape having cross-section area increasing from start to outlet, and this is done to have accommodate increasing mass of the fluid to have constant velocity of the fluid. The process handling main parts of centrifugal compressors. Broadly, we have three parts: impeller, diffuser, and casing, because these are the main three parts which handles the process gas. Now impeller, you can see the various impeller. This is a open impeller, this is a closed impeller. In open impeller, you see one side is a shroud, another side is open. In closed impeller, both side having shroud. So gas comes here and comes out from here. Here gas comes here and goes out. And so this is another photograph. It is attached to the, both are closed impeller. This is closed impeller, this is open impeller. So two types broadly, impellers are available in the industry. One is open impeller, another is a closed impeller. In open impeller, we have only one shroud, other side is open. In closed impeller, we have both sides shrouded. I mean, both end shrouded. It is closed impeller. And based on the, bend profile, it can be backward. Your bends are, backside of the rotation. This is rotation. This will be backside. This is backward impeller. This is radial. And this is forward. This is rotation in this direction. Blade is also coming in the same direction. It is called forward impeller. So three types of impeller are possible. Diffuser, as I said, diffuser can be of it is of, increasing area to convert high velocity gas into the pressure. And diffuser can, it is installed on downstream of the impeller. So diffuser can be fixed vanless diffuser. This is a plate where there is no vanes on the diffuser. This is another view of this. This is a vaneless diffuser. Another is a vane diffuser. This is a vanes are attached to the plate. So this is a fixed vane diffuser. This is a fixed vaneless diffuser. And third one is, if vanes are movable, this is a movable, diffuser guide vane. This is used for control purpose. Then casing, the main function of casing is to accommodate increasing mass flow to have constant velocity. This shape of casing is spiral, meaning increasing cross-section area. It has also function to convert velocity into pressure. So see, this is block. So gas is coming like this. You can see here, gas comes out. Same, there are different shape of diffuser. You can see here, moving like this. Here moving like this. Here is moving like this. So different, various photo of, casing. It is also called volute or housing. And Euler head of centrifugal compressor. Total energy imparted to gas is diffusion. Due to diffusion, we can write half into V1 square minus V2 square. Centrifugal action energy imparted half into U2 square minus U1 square, and kinetic energy head is half into C2 square minus C1 square. So total energy imparted to gas is half into V1 square minus V2 square plus half into U2 square minus U1 square plus half into C2 square minus U1 square joule per kg. So total energy imparted is Euler head. So Euler head we can write half into V1 square minus V2 square plus half into U2 square minus U1 square plus half into C2 square minus U1 square, and Euler head is equal to enthalpy change through the compressor, that is enthalpy increases, enthalpy rise, where V1, V2, U1, U2, C1, C2 are inlet, mean relative, outlet relative velocity, inlet mean, imperative velocity, outlet imperative velocity, inlet mean, absolute velocity, and outlet absolute velocity respectively. Units are in meter per second. Now, typically for compressors, we have two types of, normally actually there are three types of efficiency: isothermal efficiency, isentropic efficiency, and polytropic. However, we broadly discuss only isentropic and polytropic in the industries. And so it has been defined as isentropic efficiency, defined as the ratio of isentropic head and Euler head or enthalpy change. You can write isentropic efficiency is equal to isentropic head upon the Euler head, and similarly polytropic efficiency is defined as the ratio of polytropic head and Euler head or enthalpy change. So polytropic efficiency is equal to polytropic head upon isentropic head. This is a, you know, graph of efficiency correction factor versus inlet actual flow design percentage. So if it is 100%, you see this is 1, and this side also is decreasing and this side is also decreasing lesser than 1. So if the machine is operating at the design flow, the efficiency correction factor is 1, which is best, and if you don't operate it, it is higher or lower side, efficiency correction factor will be lower, and that will impact the performance of compressor. Isentropic head we know, because compressor can generate isentropic head. So once isentropic head is calculated, how Euler head into isentropic efficiency? Euler head nothing but enthalpy change. Similarly for polytropic head, oh sorry, it should be same thing written, it should, but correctly it should be written as polytropic head is equal to Euler head into polytropic efficiency. Please correct it. This should be polytropic head and this should be polytropic efficiency. And then pressurize. Once you know the either isentropic head and polytropic head, you can calculate the you can calculate the pressurize based on the gas composition and inlet condition of the gas. And this is how we can calculate how much pressure has generated by compression. Centrifugal compressor power is expressed as mass flow rate into isentropic head rise into isentropic efficiency into 3600 into 1000. In terms of polytropic, we can write mass flow rate into polytropic head rise in divided by polytropic efficiency into 3600 1000, where P is a power in kilowatt, M is a mass flow, kg per hour, HSSP is isentropic polytropic head rise in joule per kg, and ESEP is isentropic in polytropic efficiency. Now, there are two important points for the compressor surge and choke. There are 2 points. This is the point which is called minimum flow maximum pressure rise is called surge point, and operating the machine left side of this point is not advisable. This is another point which is very important called the choke point or the stone wall point, and this is a maximum flow and minimum pressure rise, and below this is not again advisable to operate the machine. So compressor should be operated in between surge and stone point. The x-axis is a mass flow rate and y-axis is discharge pressure, and we have surge point and choke point or stone wall point. choke point Choke point and a stone wall point both are same. Now let's understand a little bit about what is the surge line and surge control line. X-axis is mass flow rate, Y-axis is discharge pressure. We have a different curves, either on different speed or different IGV position. So connecting all the surge point is called surge line. And we should have some safety margin, from the surge line, which is parallel to surge line, is called the surge control line. So this is surge control line, this is surge line. And similarly, all the point connected to the choke point or stone point is called stone line or stone wall line or choke line. And this is operating points. The operating point should lie in between surge control line and the choke line. This should be surge control line. So I hope you have enjoyed the session. Thank you. Thank you for watching.